Hi friends, this is the third episode of Heliocentrism web series, The Numbers Those Excite. Now, till now we have finished how the revolution started from geocentric to the heliocentric. What is the science behind that in the last two episodes. Now in this episode we will discuss what are the numbers related to that. So, just a quick recap, we have already seen that this geocentrism started around 2nd century AD given by Ptolemy. And after that, many scientists, Copernicus, Galileo, Tycho Brahe, Kepler, all were in the quest to prove the heliocentrism model. And finally, the Kepler was successful in proving that. It took so many years to prove that heliocentrism. But Kepler couldn't answer one of the key questions, why all these planets revolve around the sun. Sir Isaac Newton told us around 1665 that it is the force of sun gravity which pulls towards the center. And this sun gravity is the responsible for all the planets revolving around the sun. But the question comes that is this force sufficient enough to pull all these planets? And we are going to see few numbers related to that that can excite us. So let's start what the Newton's gravitation law is. So Newton told us that if you would like to calculate the force between the two heavenly bodies, this is the formula by which you can evaluate gmm upon r square. So this force depends upon what is the mass of these two heavenly bodies and what is the distance between those. So let's see how it is in our solar system. So let's start our journey from the mass. Question comes, how much is the mass of the earth? If we weigh the earth, it approximately gives us 5.98 into 10 to the power 24 kg. Now, is this number big enough? That means after 5 there are or 24 digits are there. Oh my god, that's a huge mass, isn't it? Now let's compare this mass with all other planets. How other planets' mass is. Okay, so who is heavier among the planets? Let's assume that the mass of the Earth is 1 unit for time being. So this is the mass of the Earth 1. If we compare the Venus, it is 0.18, slightly lighter than the Earth. Similarly, if you see the Mars, it is 1 by 10th approximately of the mass of Earth. Mercury, much smaller, 0.055, 1 by 100th. Uranus, it's a 14.5 times heavier than the Earth. Neptune, 17.15 times heavier. Saturn, 95.16 times heavier. Oh my god. Then Jupiter, it's a 317 times. That means in all the planets, Jupiter is the heaviest planet, isn't it? Now, let's see how much is the mass of the sun. If you compare the mass of the sun, it is 3,33,054 times heavier than the earth. Oh my god, that means if you combine the mass of all the planets, it is coming approximately 446.61 times, and there is no nearby. Okay, this is too much heavy. Now, if we put things in the perspective, let's say if I put all the planets on the one side of the scale, okay, their mass I assume it's a 1 unit. And on the other side, if I just put a sun will be heavier by 745 times with respect to all the planet mass. It's amazing. That's why sun is so much heavy. Concentrated mass is there in that. Now, let's compare how big these planets are. Okay, so again, first we should know how much big our Earth is. If you see the Earth, it is approximately 13,000 kilometers in dia. So, it is because it's a sphere, but for our comparison we will see the volume of this. It's a sphere, so if we compare the volume of this earth, it comes out to be approximately 1.08 into 10 to the power 12 kilometer cube. It's a huge. See, after there are 12 zeros and it's in kilometer. 1 kilometer is so much, we know already. Now, let's do the similar kind of comparative study with all remaining planets with respect to volume, and let's see what things comes up. So, assume our Earth volume is a 1 unit, and then Earth is a 1, Venus is 0.857, Mars 0.151, it's a 1 by 10th again, 0.056, 1 by 100th, approximately in size again. Neptune 57.7 times bigger than the Earth. You can see the size also, it's so much big. Uranus 63.085. Saturn 763 times, okay, in size, in terms of volume. Jupiter 1413 in volume. So, in all the planets, if you see, Jupiter is the biggest planet. But now let's compare this in front of the sun, how it looks like. Oh my god, this is 13 lakh 1018. It is not even in thousand, it's a 13 lakh. So much heavier. Now, let's put this in the perspective. So, if you see, this is our Earth, Venus, Mars, Mercury, Neptune, Uranus, Saturn, Jupiter. So, what we see, Jupiter is the biggest planet, isn't it, in all our solar system. But when you put in front of the sun, see, they looks like a toys. Okay, sun is so much big and all these planets, they are looking like a very, very small toys. And see our Earth, which is here. Oh my god, nothing in front of this. So now let's put all these things in a little bit more perspective to give us the feel that if I take the entire sun and start filling the earth inside this, it will take approximately 1.3 million earth to fill up the volume of the sun. Sun is so much big in comparison to the earth. Okay, now if you see, let's say this is the ball, football is there, which is our sun. Then you see the one dot, that one dot will be the earth. It is so much big. So all these data is just to give us the feel sun is not so small, sun is a very, very big, sun is too heavy. Now let's see how these planets are located with respect to the sun, how far they are, because then only we can compare the gravity, okay, gravitational force. So in order to understand that, this is our sun and this is the earth. The distance between the sun and the earth is too huge. So we don't use the meter and kilometer, we use the different unit we call astronomical unit, and we denote by 1 AU. And this 1 AU is a huge number. Okay, so it's like a 149,597,870 kilometer. It's a so much huge number. So in simple, 1.5 into 10 to the power 11 meter. It's a huge number. Now let's see how our planets are located. So if you see, this is the flow. So this is our sun. Within the 1 AU, all three planets are covered: Mercury, Venus and Earth. After that, Mars and Jupiter are within the 5 AU. And see, they are going so much far, so much far. Like Neptune is at a 30 AU, 30 times of the distance between the sun and the earth. They are too much far and we are here. Now, so the question comes, why all these planets revolve around the sun? Okay, how much this force is? Is this force sufficient enough? Let's take a sneak peek in that. Before understanding, let's see how much the force our earth apply. We know that on the earth's surface, if we keep any object it falls down. Why? Because the earth is applying a force towards center. We call the gravitational force. That force is 9.81 Newton per kg, or approximately 10. This we also call acceleration due to gravity. Now, the meaning of that, if you take a small mass of the apple, 100-gram mass, and if you keep in your hand, it will apply a force on your hand by 1 Newton, just to give us the feel. Okay, so this is the force of 1 Newton. Now let's see how all these planets apply the force, how much that force is. If you take the Earth is 9.81. Venus apply the force 8.87 approximately. All these numbers are in Newton per kg. Mars apply 3.77. Mercury 3.59. Uranus 10.67. Saturn 11.08. Neptune 14.07. And Jupiter 25.95. That means approximately 3 times than Earth. Okay, so what's the meaning? Now, how much is the Sun apply? That's the next question comes. 274.13, isn't it? 274.13. That's a huge number in comparison to these. Now, if we combine all these forces from all the planets, okay, that is adding up to 87.81, but only the Sun alone is capable of applying 274.13. That's why all these planets are revolving around the Sun. Are you getting now? So stay tuned for more learning. Thank you.